Right, today we're going to be looking at tension now. Tension is, think of it as an addition to Newton's laws. And the definition is a force exerted by an object that can be stretched, right? There's different forms you can think of, like wires, chains, elastic bands. There's tension for all of these objects, right? I'm going to jump straight into tensions questions. I'm going to do one question and then I'll upload some more videos on tension at a later stage. Right, so let's look at our question first of all. Right, two crates, 10 and 15 kilograms respectively, are connected with a thick rope. A force to the right of 500 newtons is applied. The boxes move with an acceleration of 2 meters per second to the right. One third of the total frictional force is acting on the 10 kilogram block, and two-thirds on the 15 kilogram block. Number one, calculate the magnitude and direction of the total frictional force present. And number two, the magnitude of the tension T in the rope. Right, let's have a look at this over here. Okay, I have drawn it for you in the starts just so that we are clear as to what is happening. Here we can see I have drawn my two blocks of 10 and 15 kilograms and the tension in between, which is my rope. My force is being applied to the right of 500 newtons. There you can see my acceleration is 2 meters per second. I've also indicated to the marker which direction is positive, which is to the right, as well as to the top over there. Right now, I'm going to, for this total friction, because they've asked for the total friction, I'm going to take all of this over here, all of this as 1 unit. Right? There is another way to solve this, and it's to solve it simultaneously. But for this, I'm just going to give you the quickest method. Hopefully this will help you because I see that my students seem to understand that a lot easier. So I've got my 10 and 15 kilograms. My whole unit over here, my whole system is going to be a total of 25 kilograms. There you go. My total mass is 25 kilograms. So I'm going to use the formula F net is equal to MA, which is equal to my F applied plus my friction. But generally, we know that friction goes in the opposite direction. Therefore, F applied is plus friction is equal to MA. So I've just rewritten that, but I am going to be looking for friction. So I'm going to take F applied over, and my F applied is going to change from a positive to a negative over there. What is my mass? 25. My acceleration is 2, and my applied is going to be 500. Notice the negative and 500 over here, which is going to be 50 minus 500, which is going to give me a total of 450 newtons, which is going to be to the left. Remember, my negative sign over here is just an indication of which direction it is going to be moving. So I can see this is going to be moving to the left over here. Now I want to calculate this over my different magnitudes of tension. Now, please, we must understand that tension's magnitude over here will be the same for both 10 kilograms as well as 15 kilograms. My tension's magnitude will be the same, but it will be in opposite direction depending on which one I'm looking for. If I'm looking at this 15 kilogram, I can see that I am applying a force to the right. I am pulling this object, which is going against this 500, and my tension is going against this 500 newtons. So I have two things that are going against my 500 newtons over here, which is my applied force. So if I'm looking at this object here, notice I don't have an applied force anymore. I've got a tension. So it's this tension as well as this my frictional force moving in this direction over here. Right, so when I'm looking at this object, it's going to be that and that over there. So let's look at my first one, which is going to be my 15 kilogram here. Okay, so I'm going to say F net is equal to MA. F applied, which is this one here, plus my tension plus my friction for this over here. And my friction, they have stated over here, is 2/3 on the 15 kilogram block. So I've calculated my overall friction. So all I do is where this friction is, it's going to be 2/3 times 450, or a negative 450, which will give me negative 300 over here. And you can see my mass and acceleration, 15, acceleration 2. So I've substituted that. 500 minus 300 is going to be a positive 200, plus t equals 30. Take it over. Now I've got a negative 170. So you can see for this one over here, if I'm looking at this object here, it is going to be my F applied minus my friction, which is this here, minus my over here, minus my friction, which is this, minus my tension. That is going to be my MA over there. That is what is happening here, which is the same as this over here. I've just already inputted my negative values because I know the tension is going to be negative, and we've already seen that friction is also going to be a negative. So I've already put it in. But we know that if we have to put it in again, we can just put a pluses over here, and inside these ones over here, we know that they're going to both be a negative. Now that I'm looking at this tension over here, for this block over there, you can see it's tension plus my friction is equal to my MA, but we know that this friction is generally a negative over there, so it's technically tension minus friction is equal to MA, right? So there you can see, just generally always put a plus, but we know that friction is going to be negative. So I'm going to have friction, but we know that my friction for my 10 kilogram box is 1/3 for my 10 kilogram, okay, for my total friction. So my tension plus over there, 1/3 of my 450, my 1/3 of my total friction was my total friction, equals mass times acceleration. Notice my mass is not 15 anymore, but 10, because we're looking at that one. Then you're going to have tension plus 100 or negative 150 equals that. I take that over the equal sign. You can see it's going to go from a positive to a negative. So tension is going to, this one should be a negative actually. Positive times a negative and negative. Take it over. So I'm going to have positive 170. So you can see for this block, my tension is going to move in this direction. And then for this block over here, my tension is moving in that direction, right? And that is your tension questions. I will be posting a lot more in the future. Thank you.